Okay, let's look at the roots of complex numbers. Now, first things first, I believe that the formula was copied incorrectly and pasted off of Google Docs. If memory serves me right, cosine is up in the numerator, and that's not true. So please adjust these two binomials. Cosine and I sine should be outside the parentheses. They should not be in the numerator. So I'll give you a second to type that in. So here, if you have n is a positive integer, r is a positive real number, theta is in degrees, then there's a non-zero complex number, r cosine theta plus I sine theta, that has exactly n distinct roots. All right, given by this formula, the nth root of r times the cosine of theta plus 360 times k. Those are going to be revolutions around our circle. All that divided by n, the number of roots we're looking for, and you have the same setup for sine. Well, I'm going to use this shortcut compact form, but you can also have theta be 2 pi times the k instead of 360k. All right, so example time. Find the 3 cube roots of -8 in rectangular form. Well, the cube root of -8 is -2. We have to find 2 more roots. That's what we have to go find. So we're going to turn our -8 into a complex number. There's no I to it, so it's -8 plus 0i. And I can graph that. The real number, -8, in this direction, no up or down. So there's my vector. So it has a vector, or r, magnitude of 8, and my theta is going to be 180 degrees. So you can just take this positive distance, or you can plug the numbers into your formula. So I now have 8 CIS 180 degrees. Well, collect all your data. N is 3. We're looking for 3 cube roots. R is 8, and if you want to put right below that, the cube root of 8 is 2. So we have it here, but as a negative, but it's going to be a positive. Theta is 180 degrees, and k is going to be 0, 1, and 3 minus 1, 2. So here's the nth root formula in shorthand form. So there's my nth root of 8, that's the 2. There's my theta, plus 360 times k all over 3. Let's simplify this. 3 goes into 180 degrees 60 times. 3 goes into 360 120 times. Now, this is the important statement here. Now, I'm going to do this all written out, and then we're going to look at a shortcut. So we're going to let k equal 0 first. We got to do all 3 of these statements. That will get us our 3 cube roots. So 2 times CIS times 60 degrees plus 120 degrees times 0. That cancels out. So here's my first answer in trig form. Okay, 2 times the cosine of 60 degrees, that's 1/2. Sine of 60 degrees, that's the square root of 3 over 2. Cancel the 2's. There's my first cube root. Then we're going to put 1 in for k. So we change the 0 to a 1. So 60 degrees plus 120 degrees is now 180 degrees. So 2 CIS 180. Well, cosine of 180 is a -1, and sine of 180 is 0. So this cancels out. 2 times -1. Okay, there's the -2 from doing the algebra, your calculator version, if you will. Then for the third one, we put 2 in for k. So now 120 times 2 is 240 plus 60. That makes us 300 degrees. So 2 CIS 300 degrees. Okay, that's a 60-degree reference angle, but it's down in quadrant 4. So this was a 60-degree reference angle in quadrant 1, so my x's, my cosine, will stay positive, but now my y dropping down into quadrant 4, this becomes negative. So it's just like this with a negative square root of 3 over 2. And that's going to become 2's cancel 1, 2's cancel minus I square root of 3. And there's my answer. Now, you can double check this, We go to your calculator, we take all three of our answers, and we cube them, and lo and behold, they all become -8. But again, make sure your calculator is in A plus BI complex mode. All right, you have to make sure that your calculator is in that complex mode. So make sure you go to mode, change real, put your cursor on A plus BI, and highlight it. All right, now for the shortcut, let's go back to all this notation. This is a lot of writing. So I'm going to bring in my iPad, and we're going to look at probably the easier way to find this. And if you notice, I'm covering up the excess parts you don't have to write out. I'm starting right here. Now, if you notice, this is what we're adding every time. So in my first statement, right here, this is what I like to do to solve this problem. I write down the 2 CIS 60 degrees. So I write this down. Then I take this knowledge right here that I have to add 120 degrees each time. So I go plus 120. And I write down my next statement. Then I add on another 120 degrees. I write down my next statement. And if you want, you can always put in your 60 degree, square root of 3, 1, 2, if you need that reference error. But then I go from here and then just fill these out. Because this is the most important part to understand, that you're constantly adding 120 to this first answer when it's a 0. Then add 120, boom, 180. Add 120, boom, 300. You have these three done, all in trig form, just like that. You just found the three answers, but then you have to convert them into rectangular form. All right. Okay, and the last example 5, find all fourth roots of -8 plus 8i squared root of 3. Write your roots in rectangular form. We're not going to worry about graphing the roots. That's just basically putting them in the appropriate quadrant. Okay, so again, whoops, come back here. -8 plus 8i squared root of 3, we need to know our x, -8, and our 8 square root of 3, that's our y coordinate. This is going to start us off in quadrant 2. So that's where my theta is at. Now, I've got a hint here. Another square root of 3. Another 30, 60, 90 right triangle. So in quadrant 2, I either have 120 degrees or 150 degrees. 120 would be a 60 degree reference angle. 150 would be a 30 degree reference angle. So I have that in the back of my mind. So now I know it's in quadrant 2. Let's just go find r and theta. So r, whoops, I forgot we did theta first. -8 square root of 3 over 8. 8's cancel. Go to my calculator. Inverse tangent of a negative square root of 3 is -60 degrees. Okay, it's a 60 degree reference angle, but I got to be in quadrant 2, not down in quadrant 4. Add 180 to it, puts me at 120. There's my theta. Okay, here's my work for r. -8 squared, or just call it 8 squared. 8 square root of 3, square that. 256. The square root of 256 is 16. There's my r. So 16 CIS 120 degrees is my trig form. Now, go to the formula. N is 4. So 4 minus 1 is 3. So now K goes 0, 1, 2, 3. R is equal to 16. The fourth root of 16 is a 2. Lots of 2's for the r here. And we got our theta of 120. So 2, that's the fourth root of 16. CIS 120 degrees plus 360 degrees times K, all over 4. Reduce this. right, so again, let me go our iPad here. Bring this over. And let's write down all of our 4 answers real quick. We know we're constantly going to be adding 90 degrees to each one. So 2 CIS 30 degrees. All right, add 90. 2 CIS 120 degrees. Add 90. 2, whoops, come back here. 2 CIS 210 degrees. Add 90 to get the last one. 2 CIS 300 degrees. And now we'll go find all these answers here. So we got to find cosine and sine of 30. Cosine and sine of 120, that's a 60 degree reference angle. Cosine and sine of 210 in quadrant 3, that's a 30 degree reference angle. Cosine and sine of 300, that's a 60 degree reference angle. Okay, so then we'll go find it. Now, I had to make my PowerPoint look pretty, so I'm going to write this out, but you don't have to. We know the shortcut. So we know that the sine of 30 degrees is a half, and the cosine is going to be the square root of 3 over 2. So you're going to see these answers quite a bit here. So 2's cancel, leaves me the square root of 3 plus I. Okay, our next one was 120 degrees. Again, we don't need to write this down. So 120 degrees, 60 degree reference angle. Cosine of 60 is 1/2, but it'll be a negative 1/2 because that's quadrant 2. And I'll have a square root of 3 over 2 for sine. Cancel the 2's, negative 1 plus I square root of 3. Our next one was the 210, 30 degree angle. Okay, wait a minute. That's a 30 degree reference angle too. Okay, but this is going to be quadrant 3. So quadrant 3 is negative, negative. So let's just copy this down and put negatives on the inside. Oh wait, that just makes both of these answers negative. Love it when you find patterns. Then we had 2 CIS 300 degrees. That's a 60 degree reference angle. So this was a 60 degree. So it's going to be these same answers, but now sine. Quadrant 4 is positive x. That's cosine, negative y. So switch the signs on these two. So, okay, switch the signs on this. 1 minus I square root of 3. And again, if you want to build your triangle and build your 30, 60, 90 reference triangle in there, that's fine. Use those values. All the power to you. But use your calculator. Come back here. I'm not done with you. To grade this. This was our original number, negative 8 plus 8I squared root of 3. Type it in the calculator. In complex format, this is the decimal you get. But notice I took all 4 answers, put them in parentheses, and raised them all to the 4th power. And all these decimals are the same. So these are the 4 roots that when you raise them to the 4th power equal this number right here. And that's how you do and find all your roots of complex numbers.